Hello, I'm Francisco Herrera, and this is my second video, and I'm going to create the OR logic gate. So, as you can see, I already have the OR logic gate here set it up, and I'm gonna take it apart to do it again. I'm gonna disconnect the power source first, take out the lamp. So for this gate, we're gonna use the same materials. We're gonna use the breadboard. We're gonna use a LED light, and the only difference is that now we're gonna use more jumper cables. We're gonna use 1, 2, 3, 4, 5, 6, 7 jumper cables. Our 2 transistors, the controller board with the 2 jumper cables connected to the 5 volt source and the ground, and our power source. So we're gonna start by setting the resistor. We have our resistor, and then we place the first transistor. So the collector of the first transistor is gonna be lined up with the resistor, and then we place our second transistor. We're gonna place it away from the first transistor so we can have more space. So now we connect our transistors. So we to do this, we're gonna connect the first transistor's collector to the second transistor's collector. And then we connect the emitter of the first transistor to the emitter of the second transistor. So now we're gonna put the switches on the transistor in order for it to have the inputs on. So we have our two switches. We placed our LED light connected to the emitter of the second transistor. And now we connect our 5 volts, and we connect our ground. Let's do it the other way. So the LED light is now connected to the ground. And now we connect our power source. And there, we have our LED light on. So in this OR logic gate, it doesn't matter which transistor is on. The LED light should be on with only one resistor. So we disconnect the second transistor, and the LED light is still on. And we disconnect the first transistor, and the LED light is still on. So if we disconnect both transistor, our LED light is gonna be off. So there. Here's a closer look to the OR logic gate circuit. So we have our transistors, we have the switches, and these two transistors are set in parallel. So the way of knowing is that this jumper cable is connected to the collector of the first transistor to the second collector of the transistor. We have the this jumper cable connected to the first transistor's emitter to the second transistor's emitter. So here we disconnect the first switch on the first transistor, and the LED is still on. Here we disconnect the second transistor's switch, and the LED turns off. So you just connect it back, and this one we connect it back, and there. So here we have our logic gate diagram of the circuit. We have our 5 volts, we have our 1 kilo ohm, our 2 transistors, and our LED light. So the current flows from the power source to the 1 kilo ohm, and it stops right here. Since none of our transistors are connected, the current will not flow to the LED light. So if we connect this transistor to from the collector to the base of the transistor, the current will flow through here and will go through the LED light, and our LED light will be on. We connect our second transistor, and the current will flow through here and also will flow through the second transistor, and the LED light will be on. So it doesn't matter which transistor is connected, the LED light will be on. If we don't have none of the transistors on, the LED light will not be on. So we have our parallel transistors, And this is how the OR logic gate works.